Right, we're not going to be very long because the rest of the students are actually preparing for the tests. The March tests, controlled tests are in full swing. And now we are looking at exponents and surds, and we are actually attempting to solve for x. And as we are solving for x, we have been given these few questions. And now we need to solve for x, given x to the power 2 over 3 equals 4. Right, so what answer or answers did you get to the first one, Senulu? I'm interested.
8, sir.
You got 8. Okay, that's fine. We are practicing here. So we have x to the power 2 over 3, and I decided to put this small one. There's a reason why I decided to put this small problem. There I got it from a worksheet that was set in Cape Town in the Western Cape for some students a couple of years back. And now it was in 2017 to be specific. It was a worksheet for the FET students in the Western Cape province. But now, if you look at these, what is the solution? So yeah, okay, I understand you got the answer there. Let's just do it together. So there are a couple of ways to do this question. But first things first, you need to first remove the base of the exponent. So if you have x to the power 2 over 3, you cube. And then if ever you cube the left, you also cube the right. And this is therefore x squared equals, because now if you cube like that, what happens is these 3 cancels, and if you cube 4, you get a 64. Okay, that we know so well. And right, so the next thing is now we have x squared equals 64, a very nice little problem. So if you have x squared equals 64, what then is the answer to this here? So, right, we continue to solve this, but to solve this in detail. Right, if you have x squared equals 4, then what we do is we apply the square root on the left, and we apply the square root on both sides, the left and the right, and you put plus or minus like so. So that x, therefore, is plus or minus, right? The square root of 64 is actually 8. So there are basically 2 solutions to this. So you can actually, therefore, say hence. As a consequence, you can then say hence. What we then have is that x is equal to 8 or x is equal to minus 8. And these are the solutions. X equals 8 or x equals minus 8, and these are the solutions. So as a consequence, we have solved this. I know there's a chance of students leaving out one solution, because some students can just come here, and that is the trick with this, because it becomes a square. So square equations are quadratic equations that need to have 2 solutions at most. So in other words, here, when some students will just look at this and be like, okay, it is x to the power 2 over 3, and then this is 4, and then the student is going to come and say, okay, if it's 2 over 3 like this, you can raise it to the reciprocal of this and say 3 over 2, and raise it to 3 over 2. Some students will just do this. And then the students will come and say 2 cancels, 3 cancels, and then they'll go to their calculator and say x equals 8, you know. But now the actual problem with this is the minute in mathematics the students do this, it's an error. Right, so this solution, it's a solution in error. Why? Because there is a 2 like this. So in mathematics, when you raise x to 1/2, it becomes a square root. The square root means we need 2 answers. We need a plus or minus solution there. So, and hence that is why the best is to make sure you first eliminate the bottom, have a nice view of the problem, and this is x squared equals 64. Every x squared problem needs 2 solutions because it's x squared. Right, why? Because there are 2. If you say there's the square of a given real number x, the square is 64. How many real numbers can you square to get 64? Okay, 8. Yes, 8 squared is 64. What about minus 8? Because also minus 8 If you square minus 8, you also get plus 64, because if you square negative, you get a positive. So obviously, inevitably, there are two solutions to this particular question. So yeah, it's something to just be very careful of and to note with great caution. So we look at the next problem. 3 to the power x. 3 to the power x. Right, into x minus 5 is less than 0. 3 to the power x into x minus 5 is less than 0. Now, let's look at this one. Now, this particular one is a very, very interesting question. Right, so I know that Cyril was trying this one. What do you think, Cyril, of this particular question? They can ask you this one, but yeah, stupid question in question 1. They can ask you this in paper 1, you know? So if they ask you in the first paper, you told me you're a little bit stuck with it. I mean, I know that is a very interesting one, but also it's a very nice little problem. So your take on this particular question, Senator? What would you do in matric? You walk into the exam and this question is there. Question 1, there's always an inequality, less than 0, greater than 0, something of that sort. It's always there. And they give you these. Now, what do? Do you just leave it and throw away the 3 marks that will cover this, or what? Because
No, sir, I tried.
you try.
But when I tried, what I
Yes.
do,
Yes.
you were supposed to equate them to 0.
Yes.
So you take the inequality, take
Yes.
both of the variables with x, and then you equate them to 0 using the inequality sign.
Yes.
But
Okay.
then after that, I didn't know what to do, because
I
the
understand.
3x, I don't know how to solve 3x
Yeah, you
to
get.
the power of x. I don't know how
Yes.
to
So
solve 3 to the
okay.
power of x.
Yeah. Excellent stuff. I like your approach. So you first get the critical values. Right. So the critical values are, you're right, are obtained when we change the inequality to an equal sign like this. And now we write critical values because the examiner cannot just see less than 0 and then equal to 0. What is happening here? Right. So 3 to the power x, then is 0, or and then we have x equals 5. Okay, so this is sort of the approach. But simultaneously, we know that the exponential function cannot be 0. So this 3 to the power x can't be 0. So if ever we multiply these two and get a 0, it means this particular one, because if multiply two things and get 0, well, it's either the first one is 0 or the second one, second expression is 0, or they're both 0, because 0 times 0 is 0. Or if the first one is 0, it's 0, the second one might not be 0, and the 0 times whatever is going to be 0. Or whatever times 0 is going to be 0. In which case, then we are dealing with a situation where 1 is 0 or they're both 0. But 3 to the power x, there's no way you can raise 3 to the power something and get a 0. It's not possible. Okay, because of that, we then say the exponential function is never 0. So meaning that x can be 5, because if ever x is 5 here, 5 minus 5 is 0. And therefore 0 times 3 to the power x is going to be 0. So the possibility of x being equal to 5 is really a very correct assumption in mathematics. So this x equal to 5 becomes a critical value. So meaning that we have only one critical value of this problem. If you have only one critical value of this problem, what do we do now? Because then we need to put it here. We need to put it on a number line. Because now we normally draw a little parabola, but this one is not quadratic like the problems they normally bring in the matric syllabus. So normally, obviously, one can cram in matric that they normally bring the quadratics. So we're going to put a 5 here, putting the 5. So we're going to study what happens to the left and to the right. So let's take a number that is to the left of 5, smaller than 5. What number is smaller than 5? A number smaller than 5, for example, and then you put here 3 to the power x into x minus 5. Right. So a number smaller than 5 can be what? For argument's sake, 0, for example. One can pick 0, a number that is to the left of 5, 0. So if you put it into the original, in this thing, whole thing here, you put 0 in the place of x, 3 to the power 0 is a 1. And then 0 minus 5 is a minus 5. And then 1 times minus 5, it's a negative. So in other words, if you pick a number, a random number that is smaller than 5, you'll get a negative number. It doesn't matter what you choose. So just put only the sign because each person can choose their own number. A number bigger than 5, random number, maybe like 10, 3 to the power 10, and then 10 minus 5. 3 to the power 10 is a positive number, very large, but 10 minus 5 is a 5, which is positive. So a positive times a positive will give us a positive like this. Okay, we're excited. Now we're looking for where this whole giant expression, this whole combination is less than 0, negative. Where is it negative? Is it when x is less than 5 or when x is bigger than 5? That becomes sort of the question. So indeed, when x is less than 5, so which means the solution is going to be x less than 5. But obviously, x less than 5 with the understanding that x is less than 5, but x is what? X is a real number. X is an element of the reals. But the negative part, we have a negative when x is less than 5. Okay, this is the kind of situation, obviously. And another student can get this problem very easily because another student can just be in the matric syllabus and say, okay, you know what? The exponential function, the number raised to x is called the exponential function. So the exponential function is also positive. So here, if you're multiplying two things, you're multiplying a positive thing in something else, and you are getting less than 0, you are getting negative. So which means that this must be negative. Then the student is going to comment, okay, if this must be negative, because less than 0 means negative, the student's going to say positive times negative is negative. So this one is always positive. So it means this must be negative. If this is negative, then the student can come and say x minus 5 is less than 0, which means that x is less than 5. And the student will just get full marks here because they would have solved these. It's just x less than 5. They wouldn't have to go through all these things because now the student is going to say, we are multiplying this with that, but the exponential is always positive, but you're multiplying with something you are not sure about. If it's positive or negative, which can be either positive or negative, and then, but you're getting something less than 0, it means this indeed is negative. So x minus 5 is negative, which means you transpose 5 and you get x less than 5. Okay, that's something that becomes possible there. Right, so, and the answer is x less than 5, but obviously x is it's an element of the set of real numbers because x is potentially a real number. Now, let us look at this one. Show that the roots of 3x squared plus k plus 2 into x is equal to 1 minus k are real and rational for all values of k. Okay, let me give you like 2 minutes to do this one quickly, Senator, and to give me feedback, please, on whether you're getting it or not. Right. Please let me know when you're done. Right. Right. So we have 3x squared plus k plus 2 into x equals 1 minus k. Solution. Right, so you have 3x squared. 3x squared plus k plus 2 is equal to 1 minus k. Right, you're done, Tenulo. What did you do? Right, so we have 3x squared plus k plus 2, because the video is going to have a lot of quiet parts, and that is why I need to communicate, because if I don't talk, the video, when you watch the video, there are times when it's just going to be quiet because no one's going to be talking there. And you'll be like, okay, is the video on or off, you know? So now that's the reason why there's to be just somebody talking here to make sure that when somebody watches the video is having sound, the sound. Right, so what is A here, Celulo?
It is 3, sir.
B is what?
B is k plus 2.
C.
1 minus k.
1 minus, yeah, 1 minus k, but it is a negative.
Okay.
Yeah, because obviously, see, it is 1 minus k on the right, but if you transpose it to the left,
Other
then,
side.
yeah, it actually attains a negative.
Side.
Yeah, and obviously I just decided to keep the negative there, but yeah, it doesn't really matter what you do. Right. I mean, it can be, well, another student can say you can multiply through by the negative here. And the negative and negative is positive, getting k minus 1. So C can also be k minus 1. So k minus 1 is also correct. Right. So now, as a consequence, delta becomes b squared minus 4a what? C in the third part. It is b squared minus 4ac, which means that delta equals b. What is b? It is k plus 2. K plus 2 squared minus 4a. A is 3. And C is what? C is minus into 1 minus k. C is minus into 1 minus k. Right, like so. Okay, let's see what we have here. Okay, now, what actually do we get? So we have delta, the discriminant, and then now we need to just square some of these things. If you square these, k squared, and then k times 2, which is 4k plus 2 squared is a 4. And then we have, you multiply negative by negative, which is a plus. And then 4 by 3 is 12. 12 by 1 is 12. And then 12 by k, particularly it's going to be 12 by minus k, which is minus 12k. Right, so let's look at these, and that's what we have. That's what we have. So which means, therefore, you have delta equals k squared. So we have 4k minus 12k, which is minus 8k. 4 plus 12 is what? It's exactly a 16. Right, so that is number 3. So we have delta, which equals k squared minus 8k. Right, check that is minus 8k plus 16. And this is, you can factorize this. Factors of k squared. Okay, it's a perfect square, this. But factors of k squared are k and k. Factors of minus 16 are minus 4 minus 4. Right, so factors of plus 16 become minus 4 minus 4. Minus 4 squared. All right, minus 4 squared is a perfect square. Is greater or equal to 0. And delta is a perfect square. Right, it is a perfect square because it's k minus 4 all squared is a perfect square. This thing sits under the square root in the quadratic formula. So yeah, the square root of a perfect square is just going to be a rational number. So in other words, this is a perfect square. It's greater to 0 is a perfect square. And because the perfect square, we make this following conclusion. Because to show that the roots are real and rational for all real values, for all values of k. Right, so yeah. 3. The answer, the roots are real. Hence, the roots are real. Real and rational. And rational for all values. Okay, it must be that they are real and rational. The examiner left a word there. They are real and rational for all real values of k. For all real values of k. So the hence the roots are real and rational for all real values of k. So this examiner also this question, I took it from Cape Town, from a Cape Town worksheet. So in the Western Cape province, but these are real and rational for all values of k. The examiner was supposed to say for all real values of k, because if ever k is not real, then the roots are not going to be real. Okay, so examiners, watch your words there. Okay. Right. Otherwise, we have this question, and we have solved this problem in detail, and we're done. I think that I'm not going to be very long because a lot of your friends decided to stay away. But yeah, I'm going to be crossing over tomorrow. It's going to be physics at 8 p.m. So yeah, you can get yourself ready for physics at 8 p.m. tomorrow. Okay, in the evening. Yeah, if load shedding does not affect us, we're gonna be doing lots of physics tomorrow, so you can join us there. I think that for today, because a lot of your friends are just writing tomorrow, they are controlled tests. Let's take a chill pill and relax a little bit. But yeah, I'm gonna see you. I'm gonna keep you posted on WhatsApp. But yeah, tomorrow is Monday and 8 p.m. is physics every week. So yeah, we can do more physics day if
Sir,
you're free.
the
Yes.
timetable, sir.
Yeah, I'm still crunching the timetable because I'm putting a lot of the subjects. I'm putting in
No, sir, the supplementary timetable. So the one I
oh,
asked.
the sub. Yeah, I'm gonna get it for you because available. Just that for some odd reason, it has just been slow for me to get it, but I'm gonna get it for you. Okay, yeah. Tomorrow I'll make every effort to get it because it's there. It's available. Okay, I just need to just locate it. That's all. Yeah.
Okay, sir, can I
Yes.
ask you something? I'm struggling with trigonometry and functions. I'm